Okay, so for the second part of this topic, we will see the motion of the particle that is moving perpendicular to the electric field strength between the two parallel plates. So what we are saying here is that we have two parallel plates, and between the two parallel plates, it is a particle that is entering with a certain initial velocity. And now, depending on the nature of the particle and the configuration of the plates, we will see that particles will obtain a path that is very similar to the projectile motion. So if we have a positively charged particle, let's say we have a proton, or we have an alpha particle, or even if we have an ion, and the configuration of the plates is here is negative and here is positive, then the particle will move like this. So this will be the motion of the particle. And if we have a negative charge, let's say we have an electron, or we have even ion, then the natural path will be something like this. And if we have a different configuration of the plates, so now we have a positive plate is on the top and a negative plate is on the bottom. And then again, we have a particle that is entering here with a certain velocity. If we have a positive plate, then we'll go toward the negative. And if we have a negative plate, the charge will go toward the positive plate. So what it is, the path that the particle is obtaining here is nothing but projectile motion. And the projectile motion, we have seen and talked about this in Physics 20, is a combination of two motion. The horizontal motion is a uniform motion, so no acceleration. And the vertical motion is a non-uniform motion. We've talked about this in physics 20, and if you haven't seen, or you don't fully remember what is the projectile motion when you have an object that is thrown at a certain whatever height, the cliff, then I will recommend you go to that video that I'm attaching, and or video series that I'm attaching, and then see that, because this will make a perfect sense when you understand what it is. Now, again, stop the video here, if not, and move to watching the videos from Physics 20, and then see and understand that approach, and come back to this video. The case of the particle moving in between two parallel plates is very similar to an object thrown horizontally from a certain height. So the path that the object will obtain when it is thrown from a certain height is something like this. Now the particle can be thrown at a very close to one of the plates. If it is a positive plate, probably will be this situation, or if it is a negative plate, will be this situation, or somewhere in between In most cases is in the mid distance between the plates, and in some cases is 2/3 of the distance, 1/3 of the distance, or whatever. So in our first example, what we will see is we'll see a particle. The configuration of the plates is like this. Here is the positive plate and here is the negative plate, and then what do we have here is an alpha particle that is entering with a velocity of 3.50 times 10 to the power of 3 meters. And what we have here is the change of voltage between the two is 120 volts. And the distance between the two plates is 2.50 times 10 to the power of -3 meters. Okay. Now, if you have seen the videos on projectile motion, then what we have done there is that we said that we build the table. So we find the horizontal component and the vertical component of the initial velocity. And on every case that you will see on Physics 30 will be that it is entering with parallel to the plate, but perpendicular to the field. And what do I mean by this is that the electric field strength is on this direction, and the direction of the motion is like the way that the object is entering is perpendicular. So this is what I mean by perpendicular to the electric field strength. Okay, so now in the horizontal, what do we have is a uniform motion. And on the vertical, we have a non-uniform motion. Having a uniform motion means that acceleration is equal to 0, and having a non-uniform motion means that we have an acceleration. And listen now. For the particles that we are talking here, force of gravity can be omitted. And I will show you an example of why, but just take it from me now. So force of gravity is way, way smaller than the electric force that the particle is experiencing between the two parallel plates, which gives us the right to say that force net, which is the vectorial sum of all the forces that the object is experiencing, is pretty much the same as the electric force. So now, based on the second law of Newton, what we have is acceleration is equal to force net over mass of the object. Okay? This is what we will use here. So now we have electric force, which, as I said, is almost equal to force net over mass of the particle that is entering in between the parallel plates. Now, on the other hand, electric force between the two parallel plates is the electric field strength times the charge of the particle that is entering between the two parallel plates over mass. So this is just the electric force. Now, on the other hand, what we have is that since we are in between the two parallel plates, the electric field strength will be delta V over delta D times the charge. So this is just for the electric field strength over mass. So you stop here for a moment and you say, can I figure out what is the acceleration of the object? Meaning, do I know what is the voltage? Yes, 120. Do I know what is the distance between the two? Yes, it is 2.50 times 10 to the power of -3. Do I know what is the charge? Yes, because you do know that the particle is an alpha particle, which is 2 elementary charge. Do I know what is the mass? Yes, because it is in your formula sheet and it is one of the constants for the acceleration. So what I recommend is you write the value. So you stop here and you say, do I know everything that we have here? Okay. And in order to move forward, we have to write an equation for the velocity. So the horizontal component of the initial velocity is the initial velocity itself. So the velocity in the horizontal will be whatever is the initial component of the horizontal, which is equal to the initial velocity itself. So it will be 3.50 times 10 to the power of 3 meters per second. And the vertical will be acceleration times time. So whatever is the value of the acceleration times time. Okay. And now the displacement in the horizontal will be whatever is the horizontal component, which is 3.50 times 10 to the power of 3 times time. And y will be 1/2 times acceleration times time to the power of 2. So the key point, or what is added to the particle moving into between two parallel plates perpendicular to the electric field in comparison to the projectile motion in the near the surface of the earth, is that what we do here, we say the acceleration is negative. What do we do there is we say that acceleration is negative 9.81. Now, why is it negative? Because it is going in the opposite direction. So in the opposite direction of what? This is the vertical, this is the horizontal axis. So everything that is below will be negative and everything that is above will be positive for the vertical. And for the horizontal is always positive. But if the object is going down, then acceleration will be negative. And if the object is moving up, then acceleration will be positive. And if anything that is below the horizontal axis will be considered as negative, and everything that is above the horizontal axis will be considered as positive. Saying this, if we have a situation when we have parallel plates that look like this, positive, negative, and we have an electron that is entering here. So the path will be something like this. So now the vertical and horizontal axis will be this way. So since it is moving up, then acceleration will be positive and the y will be positive as well. So just tweak a bit. And another thing that we have to see here, tweak a bit in the sense that acceleration can be positive and negative. And another thing is that we don't have a fixed value for the acceleration, but we either have to figure it out based on the information that we have on the question, or find it through the calculations. I hope that this makes sense. So now what we will do is we will write this table, which is the table of projectile. We call it the table of projectile with our information. So we have for the velocity, for the horizontal is pretty much completed, but let's complete the vertical one as well. So meaning that let's enter all the values for delta V, delta D, Q, and mass, and write the equations with numbers. So based on the calculation, this is what you should see. So if you enter all the information that we have as a voltage 120, distance between the plates 2.50 times 10 to the power of negative 3, charge as 3.20 times 10 to the power of negative 19, and mass 6.65 times 10 to the power of negative 27. Then you will see that acceleration is 2.30 times 10 to the power of 12. And this is, don't be scared when you see those large numbers. Now it is negative because we have the object moving in the negative, below the horizontal axis, because we always choose the vertical and horizontal to the point that the object is entering, and normal horizontal and vertical axis, X and Y axis that we have seen in math. And then the velocity will be this, and the Y, or the Y will be whatever is the equation here. Now, the question was, how long will it take to hit the other plate, to reach the other plate, and what is the range? So how long will it take to hit the other plate? And this is where we will stop and say, okay, so what do we have here? The object is entering at this point. This distance here, 2.50 times 10 to the negative 3, is it positive or negative? And since it is below the horizontal axis, will be negative. And what is it? It's the same as what is the height of the cliff on those videos that we have explained on physics, or questions that we have done on physics 20. And the height of the cliff, or the distance between the plates, is 2.50 times 10 to the negative 3. If it was midpoint, then will be whatever is the distance between divided by 2. If it is 2/3, then whatever is the distance times 2/3 of it. Okay, so now we'll start with the information that Y is equal to negative 2.50 times 10 to the power of negative 3 meters. And this is where we will start. And now why I push you to do this question on this way, because the starting point will be using the non-uniform principle. So then you will go negative 2.50 times 10 to the power of negative 3 is equal to negative 1/2 times 2.31 times 10 to the power of 12 times t squared. So negative and negative is cancelled out. Then we find the time as the square root of 2 times 2.50 times 10 to the power of negative 3 divided by 2.31 times 10 to the power of 12. Make sure that use brackets when you're entering this in your calculator. If you have an old one, or if you have a new one, then you're using fractions option. So you should have a time that is 4.65 times 10 to the power of negative 8 seconds. Do not forget to square root it. And now, after we find the time, then we can figure out what is the range. So then we'll use x relationship, that is 3.50 times 10 to the power of 3 times time, which in our case was 4.65. So 3.50 times 10 to the power of 3 times 4.65 times 10 to the power of -8. And then entering it in your calculator, you will find that the range is 1.63 times 10 to the power of -4 meters. If this is a question that they're asking, what is the range in the form A dot BC times 10 to the power of C, or negative D, sorry, meters, then you just have to record whatever is A, whatever is B, and whatever is C and D. So in this case, it will be simply 1, 6, 3, and 4. You don't have to put any negative number or anything like that. Let's see now another question that is dealing with the electron entering in, let's say, midpoint between the two parallel plates. So we have two parallel plates that look like this. It's a positive one and a negative one on here. So the electron is entering with a velocity of 2.80 times 10 to the power of 4 meters per second. And what do we have here? The plates are, let's say, 12 centimeters, and delta D is 2.50 times 10 to the power of -3 meters, and the electron is entering the midpoint. So this distance here, 1/2 delta D. Now we said that the reference axis will be at the point where we are throwing the object, and will be normal horizontal and vertical axis, and the path that the electron will have is going up. Now the question here is stating that the electron barely passes the plate. So the path that the electron will do as it is entering between those parallel plates will be going up, because the electron is negatively charged, and its natural flow will be to go toward the positive one. So will be some, and if it is barely, then this will be what will happen with the electron. So we'll just pass the positive plate, which is telling us that the range of the electron is exactly 12 centimeters. And what we will find here is what is delta B. Okay, so this will be what we will find. Okay, since this is a projectile motion and the electron is going in the positive vertical, the acceleration will be positive in the vertical direction. Let's write the table. Let's complete the table. So the table is saying that projectile motion is a combination of horizontal and vertical. In the horizontal, we have a uniform motion. In the vertical, we have a non-uniform motion. And the difference between this situation and the projectile motion seen on 20 is that we will either find or or calculate the value of the acceleration. So it's not a constant value. Acceleration is equal to 0. Now acceleration is equal to force net over mass based on the second law of Newton. I will repeat that logic again. Or since force of gravity is way too small in comparison to the electric force, then will be electric force over mass. Since you are between two parallel plates, the electric field will be electric field strength times the charge over mass. And since you are between two parallel plates, the electric field strength will be delta V over delta D times Q over mass. So what we are saying here, since we are looking for delta V and knowing everything else, we cannot find the value of this. And this will be what we will find. What is the delta V? Okay. Now the velocity in the horizontal will be 2.88 times 10 to the power of 4. And velocity on the vertical will be acceleration, which is positive, as we said, acceleration times time. And x will be 2.88 times 10 to the power of 4 times time. And y will be 1 over 2 times acceleration times time squared. So now we stop and say, what else do we know? Okay, because we will solve it. And what do we know in this case is that it is barely passing the plate, reaching the end of the plate, which means that x is equal to 12 centimeters or 12 times 10 to the power of negative 2 meters. So this is the starting point. We'll start with using the uniform motion. So from there, we will find the time. So 212 times 10 to the power of negative 2 is equal to 2.88 times 10 to the power of 4 times time. And from here, time will be 10 to the power of negative 2 divided by 2.80 times 10 to the power of 4. Use brackets, please. So this will be 4.29 times 10 to the power of negative 6 seconds. And now we take this value and we, using the fact that it is entering a midpoint, y, entering in a midpoint, y will be half of delta D, or 1 over 2 times delta D was 2.50 times 10 to the power of negative 3 meters. So y will be 0.5 times 2.5 times 10 to the power of negative 3. It's 0.00125 meters. So let's take that value, and knowing the time, we can find acceleration. So 0.00125 is equal to 1 over 2 times acceleration times time that we just found, 4.29 times 10 to the power of negative 6, the whole thing to the power of 2. So acceleration will be 2 times 0.00125 divided by 4.29 times 10 to the power of negative 6, the whole thing to the power of 2. So times 2 divided by 4. Or the answer, 4.29 times 10 to the power of negative 6, the whole thing to the power of 2. So acceleration will be 1.36 times 10 to the power 8 meters per second squared. And then we go back to what we said before, that the acceleration is delta V. So acceleration is delta V over delta D times Q over mass. Okay, and this is equal to 1.36 times 10 to the power of 8. So now delta V will be something that we will find over delta D is 2.50 times 10 to the power of -3 times 1.60 times 10 to the power of -19 over 9.11 times 10 to the power of -31, which is the mass of the electron, is equal to 1.36 times 10 to the power of 8. So delta V will be equals to whatever the calculator is giving you. I have 1.93 times 10 to the power of -6 volts. Check your calculations and let me know if you have the same answer or not. Okay, we'll see a third example and then we'll call this done. So a third example will be, let's say that we have two parallel plates. Positive and negative. And an electron that is entering into 1/3 of delta D. And what do we have here is the change of voltage is 150 volts. We are assuming here that it is infinitely. Okay. And the distance between the two plates is 5.0 times 10 to the power of -3 meters. And it is barely passing the plate. It is barely passing the plate. But we know that the plates are, let's say, 15 centimeters. And what we are looking for is what is the initial velocity. Okay, we'll do the same thing as we have done before. That we'll start with the table. So we'll have a horizontal and a vertical, uniform, non-uniform. Acceleration is 0. Acceleration, and I will repeat the logic again, is based on the second law of Newton, is force net over mass. Since force of gravity is too small in comparison to electric force, then force net is safe to say that force net is equal to electric force over mass. Now, force net is E times Q, electric field strength between the parallel plates, times Q over mass. Since we are dealing with electric field plate, then we have delta V over delta D times Q over mass. And then we stop here and say, do we know everything? Yes, we do know what delta V is. We do know what delta D is. And being an electron, we do know what the charge and mass of the electron is. Go ahead and enter those values that we have: 150, 5.0 times 10 to the -3, and Q and M for the electron, and figure out what is the acceleration. Based on my calculations, I have the acceleration as 5.27 times 10 to the power of 15, and it is a positive value because what do we do here? We have the vertical and the horizontal axis like this, and the electron, being a negative charge, will naturally go toward the positive plate. Okay, and now we continue with the rest of the equations. So we'll have velocity in the horizontal is equal to the initial velocity, which we don't know. And velocity in the vertical will be acceleration. So 5.27 times 10 to the 15 times time. And range will be the horizontal component, which is the initial velocity times time, and y will be 1 over 2, 5 acceleration, that is 5.27 times 10 to the power of 15 times t squared. We stop here and we say, what else do we know? And now what do we know is that it is entering at 1/3 from the negative plate, which means that 2/3 is the y, and it is positive, and 2/3 of delta d is the y, and will be 2 divided by 3, pretty much, times 5 times 10 to the power of -3, that is delta d. So this will be 0.003 repeating is equal to 1 over 2 times 5.27 times 10 to the 15 times t to the power of 2. You will start with this, which is the non-uniform motion. So the first principle that you will use will be a non-uniform motion. And finding the time will be divided by 5.27 times 10 to the power of 15. Don't forget to square root it. The time will be 1.12 times 10 to the power of -9 seconds. Okay, and now using the fact that it barely passes the plate, so the path actually will be barely passing the plate like this. This will be the path. Then we can say that x is equal to 15 centimeters. And will be equals to v initial times time, which we just found. And from here we find the initial velocity. So 15 times 10 to the power of -2 is equal to v initial times 1.12 times 10 to the power of -9. And from here we find that the initial velocity, and hopefully this is not more than the speed of light, because it can't be, but I'm just pulling the numbers randomly. It is 1.33 times 10 to the power of 8 meters per second. So none of the objects exceed the speed of light, which is 3.0 times 10 to the power of 8. Okay, so this is how you deal with those kind of questions, and we saw all 3 types of questions. I will strongly recommend you to try on your own, because it makes sense, but when you try it on your own, you see what you are missing. And we will deal with more questions like this in class. See you in class then.